Zoe has worked in RCI for the last 7 years and has completed both her BBTS and a master's in transfusion and transplantation science during that time, and she's recently been promoted to the senior BMS within the department, and she works at RCI Filton. So thank you, Zoe.
Talking about using alloabsorptions to aid in alloantibody ID. So I'll try and go through it quite slowly because I'm sure there's maybe not a lot of hospitals that are using sort of alloabsorptions. It's probably something that you would normally send to RCI anyway, but I think it's good to share with people exactly what we're doing, so you're not just looking at the report and seeing that we've found these antibodies. To start with, sort of what is an alloabsorption? So we tend to use a pair of enzyme treated cells with two different phenotypes, which I will show on the next slide. And then because they're enzyme treated, we want to pay special attention to the RH, KID, and KEL blood group systems. Because they're enzyme treated, your MNS Duffy antigens are going to be cleaved off. So if you do add plasma to absorb out, you're not going to absorb out anything like that. It's almost sort of the opposite of doing an enzyme panel. You would look to find a KID antibody, but because these are enzyme treated, you could absorb a KID antibody out. And generally, we use these for patients with known pan-reactive antibodies to see if there's anything underneath, or if we've previously ID'd a high-frequency antibody like an anti-U or an anti-H. Once we've got confirmation that's what it is, we can use these cells to absorb that out as well. It's a fairly sort of simple process. There's not really a lot of risk, but there is a risk that if you had quite a weak alloantibody, you could maybe dilute it because the cells are in preservative. So you have to spin them down, take that supernatant off. So we do limit it to a maximum of 3 lots. So add patient plasma to the cells, incubate, spin it down. We can do that 2 more times. Anything more than that, we just call it quits and say we can't exclude. So this is sort of a bit like an antigram almost of the cell profiles that we use. So we use the R1R1 and the little r cells 99% of the time. We would only use the R2 cell if we had a patient who was known to be little e negative, or if we didn't have an RHK phenotype. Because with your little r and your R1R1 cells, if there was an allo little e, you can see on the panel that both of the cells are positive for little e, so you've got the risk of absorbing that out. And we've also got to be cautious of patients that are big K pos in case they were little k or Chelano negative, because these cells would again absorb that out. So these are considerations that we have if we do have a patient who we see who is big K pos, that sort of has any kind of hint of a pan-reactive antibody, even a pan-reactive enzyme. We try and do the little K types. We've got it on file, so should they get worse, their serology changes, we have that type available before they've been transfused. So they've sort of got opposing types for RH and KID, and we'll keep a copy of this with the case notes as well, so we know when we're reporting exactly which phenotype we've used, because as the batch numbers change, sort of the KID types might swap on them. Like we always have an R1R1 and a little r, but you know, this one, the big K neg is the R1R1. Next time it might be the little r's big K neg. So we just need to keep a record of that with the case. So I've got 2 examples of using alloabsorptions, and for both of them, it's not for the usual pan-reactive autoantibody picture. They're both a little bit different, but how we've used them to actually ID alloantibodies without necessarily there being an autoantibody there as well. So first patient was a known patient to RCI that we had seen 4 months previously to this sample, had 2 known alloantibodies, an anti-D and an anti-JKB. They were O neg, little r K neg, and they had kidney injury and a low HB. So there's nothing really outrageous there. Doesn't sound like an autoimmune. Sounds like they might be a responder since they've already made 2 alloantibodies. So we have the panel, and I'll leave this up for a bit so we can all have a good look at it. But on first look, I'm looking at it and I'm thinking, okay, everything is positive. The auto is positive. But if we look a little bit deeper, there is some varying strength there. I can see that the D is there by enzyme in cells 1, 2, and 3. I can see the rest of my enzyme panel is stronger than my IAT panel. And then my panel, I can see I've got some reactions. I've got a plus minus, I've got ones, I've got twos. So it's not really giving too much away. But one thing I would encourage everyone to do is to look at your printouts from the analyzer. So we have those here for the IAT panel. And I feel like when you look at this, it gives a very different picture to what the antigram was showing us, because I can see much clearly now there is a lot more variation in the strength by IAT. And my auto is weaker than quite a few of the cells. So at this point, I would be thinking potential multiple antibodies, maybe cells 3 and 4 might be an autoantibody coming through, but the rest of the cells, as they're stronger than the auto, I'm thinking that could be an antibody. Too many of them to just be the JKB and the D. So the person working on this case went on to do a tube IAT, which is sort of our primary technique for clearing nuisance reactivity from autoantibodies. They omitted cells 1, 2, and 3 because we know the patient has an anti-D and we only received 1 half-filled sample. So there was no benefit of doing, we know they've got the D, so we'll do the rest of it. And again, it's fairly similar to our automated testing. Our cell 4 is coming up weak, but it's HLA pos. A lot of our patients do tend to have HLA antibodies. It's just unfortunate we can't use that for exclusions. And then with the patient having the known JKB, you can almost start pulling that out on cell 5 and cell 8. We've got the slightly stronger reactions there, suggesting it might still be KID antibodies are notorious for coming and going. But again, there's still that varying strength. The auto, again, weak by tube, weaker than the rest of the panels. So following this, the staff member decided to absorb that was going to be the next appropriate step to take, which was questionable. So I'm just going to take you through this panel sheet. So at the top where I've written AA times 3 by Chels. So they had done 3 absorptions to try and clear the autoantibody, or what they thought was an autoantibody, and then we split it into the R1 and the little r, and then we test both of those absorbed plasmas against the normal panel as we normally would, just using the 2 different plasmas. And if this was an autoantibody with nothing underlying, you would expect to do that, and then it would be negative. You can make your exclusions, and all is well. But again, here, sort of looking at it, and after 3 absorptions, if it was any kind of autoantibody, we would expect it to at least be weaker. We would expect to see some difference in that panel. But we've seen no change in strength really from our automated. So the one that's written as ERI IAT, we've seen no difference in sort of cells 5 to 10. We've still got 2s even after 3 absorptions. So it was at this point we started thinking, this is a bit unusual. We need to start thinking a little bit outside the box here. What could this be? So if we really look at that cell 4 that's been coming up consistently weaker, what's that cell negative for? Because let's say that weak is for the HLA antibody. So it's JKB neg, patient's got JKB. it's D neg and the patient's got anti-D, but they wouldn't be showing on either of those. So it's negative for big S, N, and Duffy A. I'm going to take the most common ones. It's obviously negative for some of those as well. But then if we think about those antibodies would be destroyed by enzyme. So if they were present in this patient's plasma and we absorbed using our enzyme-treated cells, they wouldn't absorb out because the MNS Duffy systems have cleaved off those cells. So unfortunately, at this point, we ran out of sample. So we had to get a repeat, and we could put some notes on the file for the next sample that we received. And we did do some looking at it, and when we looked at it, yes, that cell was negative for S and Duffy A, and if they did have an S and a Duffy A, that would match the reactivity that we were seeing with those consistent sort of 2+ reactions. So we got a repeat sample, and we tested it against a second panel that we had available in the lab. And again, we have a negative reaction. The auto was negative on this sample as well, which just makes everything generally easier. And we could see here that it fitted with the FYA, the S, and the JKB. And we did actually have to cross-match on this patient, and it's always really satisfying when you have these multiple antibodies and you start pulling them apart. At this point, we didn't quite have the 2 examples that we needed to conclusively call them these specificities. But once we could do a full phenotype, and you do your cross match and it's negative, it's always really satisfying to see. But this was a really interesting case that we fed back to the lab as well, actually, that just because something is pan-reactive doesn't mean that it needs to be an absorption. Or just because the auto is pos, it doesn't mean that whatever's there is an autoantibody. So we had a session like this in the lab to show people, to be like, so actually, what would you do in this situation? So all was well in the end. Yeah, antibodies, we confirmed them eventually. I think we had to get some donor cells from our testing lab to get our 2 examples of each of the antibodies, and cross-match was provided. And that is the first example that we had. And my second example will be a little bit more straightforward. So this one was a new patient to RCI. They were in sickle crisis, and they are an OPOS RO, so big C neg, big E neg, and K neg. And if we look at this panel, again, I look at this panel and I think there's at least 2 antibodies there, because I've got a mixture of positives and negatives. I know that on our panels, cells 1 to 3 are DPOS. It looks like there's an anti-D there. The auto's negative. And then if I do some sort of look at cells 5, 6, and 7, I can see that they're JKA pos. So in my head, I'm thinking anti-D, anti-JKA. But I just said the patient's an RO, so that would be strange if they had an anti-D. The auto's negative, so it doesn't really look like an auto anti-D. If it was reacting at 2+ by I80, I'd expect to see that coming up in the auto control as well. So again, we went on to do a second panel, and we omitted the JKA positive cells because we had concluded that on the previous panel. And again, we quite often are quite limited with the samples we get sent. So we try and do everything we can to try and save plasma. So I was really focused on finding out if there was an anti-D there. And making my further exclusions. So we hadn't excluded anti-big E at this point, and there wasn't a lot I could do to confirm or exclude it. I couldn't order any cells from our testing department because our double prime donors aren't routinely phenotyped. because there's not many cases where those sort of units are needed. So even though this patient has 2 antibodies, a D and a JKA, in order to confirm or exclude the big E, the only way that it could be done was potentially through absorbing. So if I look at the absorption cells, we used the little r absorption cells on this occasion, because if we look at ENEG, so if there was an anti-big E, it would be left behind, but they're JKA positive, so incubating that patient's plasma with JKA positive cells, that JKA would bind to the absorption cells, meaning I've got more cells available to me on my panels because I can test it against the JKA positive ones, because hopefully they'll come up negative because it will have absorbed out, which is what we can see here. So I did 2 absorptions this time, and my AA times 2. My patient's plasma against the EPOS, JKA pos cell 5, which came up positive, and then I also put up an ENEG JKA pos just to prove that I had absorbed out JKA, to make sure, I wasn't going to start blaming an E for that reactivity, but actually it was just any residual JKA. But for the guideline point of view, I need a second example because that was only 1 cell. So again, had a second panel available, did the same thing, tested it against an EPOS, JKA pos, and a JKA pos. And this case was interesting. I haven't included the panels in this one, but the anti-D, we did some work to try and see if it was an anti-LW, which can also look like an anti-D, and isn't normally too clinically significant, but they came back negative for that. So we did contact the hospital to ask for a repeat sample to send it for genotyping for the hemoglobinopathy genotype to try and determine if this patient was a variant. We couldn't do our standard testing in RCI because they were weakly DAT positive and we use an IAT technique. But sickle patients are notorious for having sort of the more unusual D variants that the genotype is the best way of detecting. So in this case, we didn't report the D type and we reported the D as not specified, because we couldn't call it either way. We had a D positive result with what looked like an allo anti-D. But unfortunately, I think I made this presentation about 3 months after this case, and when I checked when I made it, they had never sent a sample for the genotype, so I have no answers on if they've actually done that testing and if it was a variant or not. So that is it, and I appreciate that was a very quick whistle-stop tour over the absorption process. So if anyone has any questions, please let me know.
It's fascinating, but approximately how long does it take you to work up a sample like this?
Oh, isn't that the question? So generally the sample sort of comes in and everything goes on our automation for its primary panel, which sort of probably takes half an hour, let's say. And then if you're doing a second panel, that's probably another half an hour with you putting it up in the incubation, centrifuging. And then the absorptions themselves, they don't take too long. It's sort of 10 minutes incubation, 2 minutes spin, and then switching it over to the next. But we do tend to say to our hospitals sort of if it's an urgent case, it's going to be about 4 hours.
Yeah.
Especially because we get limited with plasma so often. If you've been sent 2 samples, we can just go in and whilst it's on the analyzer, we can put up some extra panels, especially if we've got an idea, the hospital have said, we think it's this and this, or, we can get started on things if we've got that extra plasma to play with. But when you're limited, you really have to wait and do things that full step by step, because you don't want to waste it. You don't want to have to call the patient back in. You really want to try and get your units out on this little sample that you have. But unfortunately, we can't do that all the time.
How helpful is it for hospitals to send in antigrams that they've worked on already? I mean, I don't want to steal from RCI Assist in any way, shape or form.
It can be useful. I mean, if it's sort of a pan-reactive case, then it's not sort of too useful. It was too much, but maybe if we were limited on sample, or if it was really urgent, it might give us an idea of things that we could do to get around it. But we wouldn't act on we wouldn't say, oh well, this panel, they've excluded XYZ, so I don't need to exclude that. But yeah, probably in the multiple antibodies, it could be, whilst we can't technically exclude on them, we could look at it and be like, okay, this makes it look like these 3 antibodies, I'm going to prioritize testing these sorts of cells. But yeah,
So ideally, as much plasma as possible.
Yes.
And with those really tricky patients, I know that some hospitals have kind of card systems where a patient has a card on the electronic patient record that says this patient has to have 2 transfusion samples every single, 2 or 3 every single time. So at least if it's 3, the hospital has 1 to keep in house. Yeah. The other 2 can go to RCI. And it just gives you slightly more flexibility, because we all know getting those extra samples after that initial one's gone off is a nightmare.
Yeah, they do take a while when you ask for a repeat, and it's understandable, but we do really try. We really do try.
Yeah, the fact that you were putting up panels and you go, I don't need to work on those cells because I'm already happy with that. Like, I never knew that, so that is fascinating to explain out to hospital colleagues, I feel. Yes, thank you so much